Welcome to this presentation, Introduction into Welding Processes. My name is Jose Roca and I'm a mechanical engineer. Now let us speak about the welding processes. We can divide it into main categories: fusion welding processes and pressure welding processes. Under the fusion welding processes, we find that first gas fusion welding process, arc welding processes, electrode. You see here also a picture on the left side. Submerged arc welding process, the picture on here in the middle, and gas welding process. This is also divided into other three categories: metal inert gas welding, metal active gas welding, tungsten inert gas welding. So under the main category pressure welding process, we find at first the spot welding processes. You see here a picture on the right side below. Two, roller seam welding process and friction welding process. Let us go back a little bit here to the gas welding processes concerning fusion welding process. So there we have three: MIG, MAC, and WIG. The most difference is that the gas is the gas that we applied. That means we use an inert gas or an active gas. Inert gas, for example, can be helium or nitrogen. Active gas can be, for example, oxygen. Concerning spot welding processes, few words. These processes you find mostly in the automotive industry. For example, if you want to fix together body parts. Now we go forward with the types of welding seams. Well, you see here some pictures, yes, of the grooves that exists, and you also see the symbols that belongs to these pictures. Here are the pictures. These are single grooves. On the right side, similar the same, but instead single, double. Well, the symbols are here that belongs to these pictures here. So we have a square groove, a single V groove, a single bevel, etc. And here also most common groove, it is the fillet or the fillet seam, fillet joint. This gives you an idea about the geometry of the edges of the place that you will fix together. For example, here the edges are 90 degrees in a square groove. But if you take a look at a single V groove, you have here an edge. It might be 45 degrees at each plate, so that you can apply also the seam. Like said, the fillet is most common. You see it also in technical drawings, all these symbols, so that you can identify your square groove, or better say your seam. So now we go over to quality standard welding. I want only spend a few words concerning this topic. So we're speaking about fusion welding, and if you work for steel welding construction, you will get in touch with the following standard norm. This is the DEN ISO 3834. This is also divided in other four categories depending on the requirements: 1, 2, 3, 4. And it also includes a PQR and VPS certification. This can be done in-house, for example, can be certified by a welding engineer if you have it as an employer in your company. And it assures your process, your welding process. If you want more information about this, you find it on the internet, for example. So a next topic, this is also important to assure quality, is the tests after. That means there exist non-destructive tests, yes, NDT tests named as abbreviation, and there exist different categories. I have written it down here. There exists a visual inspection, abbreviation VT, radiographic test, RT, ultrasonic UT, MT, and PT. When you apply one or the other, it depends on the requirements and it depends on your parts. Are they steel parts, non-alloyed, alloyed, magnetic, non-magnetic, etc.? For example, if you have steel parts which are non-magnetic and you want to apply the tests of MT, magnetic particle test, it makes no sense. So here now two examples of welding defects, welding common defects, I said, because there appears in many welding constructions. These are spatter and pores. There exist many more, yes, but I have named only two as an example. You see here the spatter, you see here the seam, and you see all the spatters around. Here something is going wrong. Maybe the current is not the correct that you have applied concerning the material, etc. Anyway, if you see visual that something is going wrong. Pores. You have here a section view of two plates that are fixed together by welding. Yes, you see here the seams and here the parts. Also here the seam and here the parts. And in this section view, you see here all the pores. If the pores are on the surface, for example, in this case, this pores, you can detect it, for example, by liquid penetrate tests. So let us go with a simple calculation by using an example. We want to determine the length and the thickness A of our fillet seam, in this case the minimum length and the thickness A of fillet seam. So what we have here a base plate with a thickness of 10. I don't have now marked here, but please remember the thickness is 10. And we have here two angle profiles. Anyway, we only have to take a look at one. The angle profile has dimensions of 50 in the length, 15 in the width, and 5 millimeter thickness. And this seam here as fillet we want to apply here in red. Now let us go on with the calculation. Before we begin, only I want to mention two conditions that are important if we apply fillet seam. I have written it down here. The thickness of material must be minimum 3 millimeter, and the thickness A of the seam must be higher or equal to 2 millimeters. You have also here the formula to calculate the minimum length, the A min and A max of my seam. Also, I want to mention that we fulfill the condition thickness of material, minimum 3 millimeters. You remember the angle profile has 5 and the base plate 10. So we come to an end. If you have questions, suggestions, or you want more information, you can contact me by email info@machinetoolindustry.es. If you want to get more information about machine tools or other topic, you can also visit my website machinetoolindustry.es. Thanks for your attention, and I wish you a good day.